10 seconds. That's all that separates a living, breathing person from being smeared across space thinner than a strand of spider silk. This isn't a thought experiment for late-night television. Physicists have run the actual equations, and the last moments they describe are stranger than any movie. So imagine it's you, falling feet first towards Sagittarius A-star, the supermassive giant at our galaxy's center, a million times heavier than the sun. You crossed the event horizon minutes ago, and here's what almost nobody expects. Nothing happened. No flash, no alarm, no wall of fire. But that calm is a trap, because somewhere ahead in the dark, the countdown to the singularity has already started, and it's about to get loud. 10 seconds out. Your instruments, if they still worked, would show the entire universe behind you compressed into one blinding ring of light. That ring is every photon that ever chased you into the hole, bent by gravity into a tightening halo, the last image of home you'll ever see. 9 seconds. Your feet, closer to the singularity than your head, feel a pull just slightly stronger, a subtle ache like a rough night's sleep. But gravity here doesn't play fair. The difference between the pull on your feet and your head is about to grow faster than your nerves can register. 8 seconds. That gentle stretch is now a real pull, your body elongating like taffy. Doctors have a half-joking name for it: spaghettification. Your spine, organs, and bones were never built to resist a force this specific. A rope pulling your head one way and your feet the other. 7 seconds. The tidal force doubles, then doubles again, escalating exponentially like a scream that keeps climbing higher in pitch. Around a giant like this one, the math says the fatal tearing happens shockingly close to the end. For most of the fall, you feel almost nothing. 6 seconds. Now the pull is impossible to ignore. Your shoulders separate from your hips in sensation, every joint screaming a warning it's never faced. Blood, oddly, moves toward your feet, pulled by the same tidal gradient stretching your body, an internal tide with nowhere left to go. 5 seconds. If a nerve signal could still travel fast enough, pain becomes the entire universe. Every cell fighting to hold onto its neighbor. Here's a detail almost nobody mentions. Your brain, still intact for now, might manage one last coherent thought before its final flicker of awareness. 4 seconds. Tissue starts to give. Not explosively yet, but the bonds holding your cells together are losing a war against millions of times Earth's gravity. This is where you, as a single object, stop being a meaningful description. What's falling now is a very long, very thin column of former person. 3 seconds. The column snaps into pieces, each one still stretching, each its own small tragedy playing out in milliseconds. From outside, none of this looks fast at all. Gravity slows time so severely that your final seconds would appear frozen into something close to forever. That's the strange split at the heart of this story. Your 10 seconds and the universe's 10 seconds stopped matching the moment you crossed the horizon. 2 seconds. What's left of you is now a stream. Individual atoms pulled apart, electrons stripped from nuclei, matter reduced to its rawest ingredients. Nuclear forces, the same ones holding together every atom's core, finally lose their grip. What tidal gravity started, raw physics now finishes. 1 second. Here, physics itself starts running out of answers. General relativity, precise until now, finally admits it has nothing left to say. Space and time stop behaving like anything you've known. Distances shrink toward zero, densities climb toward infinity, and the equations stop making physical sense. 0. The singularity. Not really a place, not somewhere you could stand, but a mathematical point where every model we have simply breaks. Some physicists think what's really there is a tiny, unimaginably dense knot of quantum space-time, governed by a theory of quantum gravity we haven't finished writing. Others think the true endpoint just hides behind physics we can't describe yet, that infinity is really our own ignorance wearing a number as a disguise. Either way, whatever information made up you, every atom's position, every memory in your neurons, has to go somewhere. Physics is fanatically strict about that. This is the single strangest argument in modern physics. The black hole information paradox, the question of whether the universe secretly remembers everyone who ever fell in. Stephen Hawking spent decades wrestling with this exact puzzle. Once convinced information was destroyed forever, then, years later, admitting he might have been wrong. Current thinking, backed by string theory and quantum entanglement calculations, suggests the information isn't erased. It leaks back out through the hole's slow evaporation. That evaporation is called Hawking radiation, a faint trickle of particles shed over unimaginable timescales, possibly carrying a scrambled imprint of everything ever swallowed. For Sagittarius A-star, that evaporation would take longer than the current age of the universe, repeated more times than atoms exist in your body. So in a sense, and this keeps physicists up at night, nothing is ever truly lost to a black hole. It's just scrambled into an unread code, which means somewhere, encoded in radiation leaking out over trillions of years, a ghost of your final 10 seconds might technically still exist. Not you, not memory, not consciousness, just information, the universe's strange insistence that nothing, not even a torn-apart body, disappears without a trace. Now here's a twist that changes everything. None of this happens the same way at every black hole. Fall into a smaller stellar mass black hole instead, and spaghettification starts long before you reach the horizon, tearing you apart in full view of the universe. But a supermassive giant like Sagittarius A-star is so large and gentle at its edge that the real violence waits patiently for the final seconds. Size, in this universe, is mercy. The bigger the black hole, the longer you get to live inside it, oblivious before the last 10 seconds arrive. There's something almost unbearably human about that. Even falling into the most destructive object physics knows, your suffering still comes down to a matter of scale. Astronomers have found black holes so massive, billions of times our sun, that a falling astronaut could drift for hours before those final 10 seconds even began. Hours of drifting through absolute blackness, watching that ring of compressed starlight shrink overhead, knowing with total certainty exactly how the story ends. No last-minute rescue, no wormhole shortcut to another universe, whatever the movies promised you. Just the equations patiently counting down towards zero. Even now, we still don't have a single confirmed picture of what a singularity actually is. Only the math, whispering the same answer again and again. That's the part that should keep you up tonight. Somewhere out there, a star's worth of matter is thinning into that last silent second right now. Maybe that's the real lesson hiding inside a black hole. Not the horror of the ending, but how much life can still unfold in the long, quiet fall before it. Somewhere between the horizon and the singularity, space and time trade places, and the universe stops making sense entirely. If mysteries like this pull at you, stay close, because the cosmos always has one more secret waiting in the dark.